Welcome to ScalaUA conference.
Okay, so hi everyone, I'm Noam Almog. I've been working at Wix in the last 4 years. During that time I was luckily introduced to Scala. Although at first when I heard that we're going to program in Scala, I didn't want to come to work there, but you know, it turned out really good, and these days I'm very happy also to see that there are so many Scala developers here in the Ukraine. One thing about I want to say a few words about Wix. I started at Wix when we were about 14 developers in the backend team. Now these days we're over 100, or I'm not familiar with the latest count. We have offices in Israel, but also in the Ukraine, in Dnipro, and Lithuania, and now we've been opening a new office here in Kyiv, and we'll be more. We'll conduct a lot of meetups, so you'll hear a lot about us. But if you're interested in us, just look for me. I'll be here, and during the conference you can ask me any question that you want. Anyway, so let's start with the subject. Why should we clean our tests? Like, usually this aspect of clean code is not really talked about, because usually we all talk about clean code. Clean code is important, we want the code to be coherent, we want everybody to understand it, and every time you write some code where if you work in TDD style, then you're writing the test, you're writing the code, you fix the code, and then you're off to the next feature because you just want to continue on and writing your code. But the test usually is the last one, the last thing that we have, and a lot of the people don't invest a lot of time in doing it. But a few facts about tests is that, first of all, tests last a lot more than production. Even if you deprecate something and you want to delete it, usually the last thing that you delete is the test itself. Another thing is that test has a lot of lines of code compared to the production code. If I know the developers that have, for each line of code, they have 9 lines of tests to test it. So it's a big challenge and it's very important to select a good structure and good methods so you can maintain this large code base. Another thing is that tests are being reviewed and read even more than the production code. Every time you add something to your code, usually you run the tests, and if something failed, then you have to understand those tests and try to see what you broke by adding the new feature. So the importance of having them very readable and very coherent for people is because if you let them rot, then basically you cannot extend your code anymore. This is one thing that Uncle Bob actually mentioned in his book. He said that if your tests rot, then your code rots too, because this is like a circle. You want to add that you want to have a lot of tests in order for you to be able to extend the system, in order for you to be confident that everything it works. But if your tests break and you don't know why they broke, then you cannot continue to implement and add more and more features. So it hurts you in the long run if you don't invest that time. So the good question is, what is good? Because we, as a company, we have a lot of discussions on what is good. And what is good is nobody actually knows, because something can be great on one thing and awful in another place, and there isn't an absolute truth. But we can actually try to measure things that are good by asking how easy to extend it. If you have a system that every time someone asks for a new feature, it takes 3 weeks to add it instead of 1 day, then you did something wrong. So a system needs to be easy to add more and more features in order for it to grow. Another thing is, if something breaks, what happens? How long does it take to fix it? You broke some part of the code, you added something, and something broke. Now you have to invest 3 or 4 days to investigate why it broke. Then it also hurt your velocity of updating and adding stuff to the system. And in the end, well, we're all developers, we all call for rewrites. So if your system is bad, then it's probably going to get rewritten in the next year. So if you judge all of your decision that you did so far, and you end up with a system that you cannot extend, or it breaks all the time and it takes you forever to fix it, and everybody wants to rewrite it, then you did something wrong. This is actually accurate, and this I can say for sure. And now that we talk about the importance of it, the lecture itself is going to be, we're going to discuss a little bit of a test structure. We're going to write a new test, refactor 3 aspects of it. We're going to have some live coding, and I hope I can keep you awake after the lunch and this long hours of many lectures. So first of all, let's talk about the structure. Why am I talking about the structure? The structure of the test, the architecture of the test itself is very important, because this is the first thing that someone sees. If someone looks at the piece of code, he can see, if he knows the structure, he knows where to look what. And this is it's gonna make it easy for someone to actually go into a new code, or actually yourself, because usually after 2 weeks you don't remember what you did 2 weeks ago, and you look at that code and you go, what the hell someone wrote here, and then you check the commit log and see that you are the only contributor. I know that it happens to many people, or at least just me. So if you look at a piece of code as a structure, I think it's very easy to imagine it as a map. For example, Google Maps have different zoom types, and the more you zoom into the map, then the more details you can see. And I would like, when I'm writing a piece of code, I wanted to imagine it like a map. So if you're looking at a specific zoom, you don't see the whole street names and everything related to it. You just see the parts that are related to that level. If you want to investigate more, you have to drill in and see more. So if you look at it as a map example, then the more you zoom in into the map, you see more and more details. But if you saw them on the higher level and you try to read that, there would be too many details. So the structure also needs to expose the right amount of details. So what does it mean, the right amount of details? Because at first, you start to write the test, and the test is written in a certain way. And I'm sorry, I forgot about that one. Another thing that I forgot, that you should try to be consistent. I know that it's going to be hard, because some of the code was written before you started something, but when you look at a project, you want everything to be consistent. What does it mean if you want to adapt to a new method or a new way of writing code? Then you still have the legacy code. So you can go back and just rewrite everything, or you can try to do a different, walk in a different path. This is why it's a little bit hard. But if you write a new project, try to make it consistent. And if you go into an old project, sometimes you want to do something really, really cool, but people wrote it a little bit different. So sometimes you have to put your ego aside and say, okay, let's do it the same way, so other people who looks at the code will still have a coherent view of the project. So anyway, we started a project which shows, we start with a test code, and it starts with this marker on the left, and the marker on the left, this is the code that you wrote to write the test. You aspire to have all the details, all the setup, everything in the same written in the test, and you want to start moving to test the code behavior. You want to have the test express the behavior and not the exact implementation of what it does. So usually you start to do that, and the best way to see if it works is to try to look at a specific test case and see if it can stand on its own. if you can look at a specific test case, not with the whole class, not with everything, and you can just read it and understand exactly what it does, then you're in a good place. So this is the one question that you keep asking yourself during the refactoring of a test. Another thing that happens is usually when you start to refactor a test, you can go too far. And if you go too far and you refactor too much, you get to a place where the test is not understandable. It's just very ambiguous. I know that sometimes some people like to write like an abstract test and run it in 5 or 6 different test cases. This is an example of an abstract test. You look at it and you don't know exactly what it tests, and the upper level, it just calls it with some parameters, and it's very difficult to maintain some sort of testing. By the way, there are ways to solve that problem, but this is probably a bad solution. So let's look at a test example, because one of the questions you're probably all asking is, well, is there a single structure that we can obey to? So I took just a single test from actually Guava. It tests the future of some behavior of the future object, and this is the test that they wrote. I changed it a little bit, but basically it's that. And the test is built from a couple of sections that we'll discuss further on. First of all, there's the description, and I know it's Java, I know it's going to hurt your eyes, but bear with me. I gave that in a Java conference as well. The Scala hurt their eyes. So first of all, there's the test description. Of course, it's in the method name in Java, but in Scala check or specs2, you can write it as a sentence, which is very nice. Another thing that you do is the given part. This is the setup part. You set up everything the environment needs to do, and then you activate the tested subject. In this case, we call future.get. Once we call future.get, something happens. And what the thing that happens is that an exception needs to be thrown, and we need to assert something on it. So this is a basic test structure. By the way, if you saw a bad structure, it usually have many, some people like to do a couple of tests in the same test. So they do something and then they verify, then they do another thing and then they verify it again. This is not a good example. But in this case, most of your unit tests will probably look somewhere in this neighborhood. And from that, let's start to refactor stuff, and let's start to write a new test. First of all, we write the test description. The best tip that I can give you as a non-English speaking person is first of all use English, because I was in a company that now when we go global, if you start to write stuff in your language, it might be nice at first, but afterward, when it goes to someone offshore, he won't like you at all. Another thing is, this is actually a bad example of what I'm trying, not a bad, this is what happens when you let an engineer write a description. It says, test cancel, not done, interrupt. It makes a lot of sense, right? And everybody knows exactly what the test does now, right? So use plain English, write a sentence that makes sense to someone who's not into the same code that you wrote. Because you know what? I'm sure that even the developer that wrote this, if you would just ask him what this test does from the test description, he will not answer it. So to find a better way to write a test description is just find a structure and stick to it. It's like I'm using what will happen if you do something, or try to find that structure and fill in the voids and say whatever the test does in the plainest English that you can imagine. And it's a good practice for English as well, by the way. But when you write test description, so if we wrote the test description, then everything is clear. Everybody knows exactly what the test does, right? Well, no, because test description doesn't compile. So the code does something, you wrote the test, and then another developer comes and he goes, oh, okay, I want that when you do something like this, you want to report to some other system. but he will never bother to update the description, and nothing will force him to do that. So even if you wrote a good test description, it's not enough. It's a good start if someone will continue to maintain it, but from me knowing myself and well other people that I saw, usually they'll just update the code, update the test, and that's it. They're done. The test description is not something that they even read when they start to write the code. On our running, this part will have, I wrote like a small code sample. The small code sample is an example of a very simple scenario. You have an API, you call a service with a site ID. The site ID will retrieve from some repository the user ID, the user email, and that user, and then he will send an external system an API call that will send an email to the site owner. It's a very simple scenario. If I'll show you the code. By the way, how many people over here are using Specs2? Scala test? Okay. Anyway, this is Specs2. They actually are pretty alike, but we started with Specs2. We're very happy with it. I'm actually a contributor to the project, but they're both very good frameworks. And anyway, I wrote those test cases. You can see from the structure right away which is the given part, which is what we're doing and what are we verifying. All of the tests are working, I hope. And everything is green. Now can go and implement another feature, but this is an example that will refactor and see how we can make it more and more clear. Not the right screen. Oh, sorry. So let's refactor the given part, the test setup. First of all, we have a lot of details on the test. Like in this case, there are two collaborators, the site DAO, which is kind of a database that stores the user information, and also there is a user DAO. And for each one of them, this is, by the way, this is Mockito. If you're using Mockito, this is the nice DSL that the Specs2 gives you. But when you look at it right away, it shows you the implementation of everything. So you want to pack it into a method that try to hide those concerns. Like, I don't want to see the return, and I don't want to see a lot of the things that's being defined as Mockito. So let's start and write like some functions. Usually I start with just taking the collaborator name and do given to actually signal someone that I'm using that structure. I'm using the site DAO, and then I'm using the exact parameters for this. And also I have the. So at first we'll just try to remove the code from the. This is user ID. We'll try to remove all the Mockito thing from it, and we'll have here user ID, and then we can use this over here, and on the rest of the test case that I have this one, I can just copy things and we're done with the first one, and let's go to the second one and do the same thing for the user DAO. And this one, a minute, the user ID. So now, when you look at the test, you don't know exactly that it uses Mockito or any other implementation, but it will remove some of the things that someone might see, and sorry. These are most of my coding errors. I copy-paste everything. Yeah, at least I know that I'm not the only one here. Yeah, after you spend debugging at 12 a.m., something that you remember, that you realize that you copy something. So anyway, the first part would be just to pack stuff into methods. The second part would be to try to give it some more meanings. So the first thing that you see is that what is interesting for us, wait a minute, what is interesting for us is actually not the site ID in this API. It's you know what, let's call it something in a little bit more plainer English, so we'll go with, and looking for usages. And basically what is more interesting for us is the none value and not the site ID. So let's reverse the whole parameters just for them to make things a little bit more easy for people to go in. Let's see if that refactor would work. I'm guessing not, but IntelliJ is making a tremendous... Okay, it did work. So now when someone looks at it, when you reverse the parameter names, at least at the parameter order, in the order of importance of someone would read it. So we're giving given site DAO with none for site for this one. Another thing that we can play with is the parameter names. So the parameter names, you can't do that in Java, but you can actually give them meaning for when someone reads that method, it would make more sense. So for example, in this case, I like to distinguish between two parts of the data that I'm sending to the method. So for example, user ID is something that is interesting for me, while this is the key. So I can use the method name, it says, say, for site ID. And if I'm doing it with a little bit more verbosity, I can have someone who reads it know that what is interesting for me is that part. And we can add it here already also. And also here. But when I look at it again, I realize that actually the none is something that it's a little bit, it's not interesting, because this is the way that we implement stuff. What I'm actually saying here is that I want a site DAO without site for this, because the none itself is not very interesting for me. So if I'm hiding this part and I'm saying this one is none, then actually I can remove part of this logic here and have someone who reads it have a better understanding of what I'm trying to do with that specific DAO. And in this case, there is I'm still retrieving stuff. So this is some of the things that we can do in order for us to make it a little bit more coherent for us. Let me close this really quick. So what we did. Another thing is that we do is. Oh wait, I think I mixed the slides a little bit, but. This is what I want it to be. What we did is this part, we extracted the method name in a way that will imply the structure. It will start with a given. It will contain the collaborator name in order for us to be able to distinguish stuff. We describe the behaviors of the object. For example, in one case that we had a none value, we changed it to the meaning of and the behavior that we expect from the other collaborator. We reverse the parameter names in order for someone who reads the sentence to get to the point really quick. And the last, but not least, is we use the verbosity of the parameters to imply someone from the outside what is the key and what is being returned to the outside. On the second, on one thing that I want you to get away from in here is that we always try to describe what we are doing and not how we do it. For example, returning none as a non-existent user site, if it was Java, it would probably be null. In Scala, we use option and use none, or maybe someone would change the contract later on and decide that a site ID that doesn't exist return -1. He probably was programming in C++, but but anyway, it doesn't really matter that value. The matter is what we try to express with this, and what we try to express is that the site does not exist. Another thing that we can try to do is simplify the code. So in some cases, like in here, we have this some user ID to know that that the user exists, but we don't really need to say that. We can now refactor this and say it always has the site ID. So, okay. And now we can save some of reduce even a little bit more from this code. We can remove another word from the sentence that confuses someone. When I was a Java developer, I used to look at stuff like that and just block them, because you see a lot of code and you just look, you manage to train your eyes. But when you look at a new code, it's very important for you to just not see all of this boilerplate and everything that's being done to arrange stuff. So by removing even some or a list or everything or anything that is looks like insignificant at the beginning, it's very important later on. So let's see that the test passes. It will. So stuff, we want to reduce the number of moving parts. We want to reduce the number of elements that someone might read. We also in this part, we don't want to. There is a bad example would be if you look at the code and you have a couple of tests that's saying, okay, there is given site DAO for this, and it appears twice, so let's drop it to the before section or something like that. This is something that you might be tempted to do if you have a lot of test case, but remember, if someone looks at that single test and tries to understand exactly what you want it to do, and it happens outside of the test scope, he won't understand it. So don't remove part of the logic that is important for the setup to an external, to someplace else in the code. Another thing is, as for concrete values, I know that it's, I personally, by the way, like to use random values. The lecture after me is going to be about actually property-based testing, which is even more excessive. But a lot of people like to use concrete values, and it's okay. But the only thing that I want you to do, or I hope you to do, is to put that inside a variable, and inside that variable, and call that variable the exact meaning of what this variable contains. The reason that you want to do that is because sometimes people have to, let's say for example, choose an email, and they're using admin@wix.com. Someone who looks at it, someone who wrote it just copy-pasted from like another test that actually used the admin as a correct value, and now it appears in your test and someone reads it and he doesn't know if admin@wix.com is important for this test or it's just a made-up email. So by calling it in a name, the variable in a name like some user email or actually using a random value, and you actually signal for someone that this is not, the value itself is not important. And the last part would be to extract drivers. After we have some section of some variables in the scope, some of them some of them belong to site DAO, some of them contain to user DAO. We can use cake patterns to actually extract those parts to another section. The reason that we want to do that is because we want to have a smaller scope for that domain. So let's try to do that, and let's call it, usually the name that I'm picking is test support. This is naming actually is the most difficult part in our profession. So the best way that I found around it is try to find like block patterns that I just fill in the void, and this is the only thing that helps me pass through the day with meaningful names. But everybody can pick his method to overcome this very difficult problem. So this is something that I need to do because of Mockito, and Specs too, but let's imagine that you didn't see that. And let's have user that was here, and we'll take also the user email and the user ID because they belong to this specific scope. Also, we can take the given methods that I wrote here and put it there. And also, let's do the same thing for ScalaUA. Oh, I moved it to the wrong trait, but so let's include the other one as well. And let's take those methods and dump it in the this is also, I think, should be in the user. And we're done with this section. So now when you look at the scope, it looks a little bit smaller, but it also packs all of the logic that's related to sites. Oh, and copy paste. What did I call it? Users. This is why I copy paste, by the way, because I never. So anyway, this is another section that we can extract some of the logic to that specific domain, to a specific section. So in this section, what we did is we moved all the setup method to a specific trait. We move also all the related variables, and we split them according to the subject. The reason for that is because it's going to be more manageable later on. And the workflow itself is actually, it goes extract setup, simplify the code, and then extract drivers or add something to an existing driver. And in fact, it's actually a process. So you do something, you finish it, then you look at the code again and you go, oh, I can remove that specific part. It's actually like a refactor structure. You go and you try and you continue to do that until you're done. One of the most common complaints is when I show stuff like that is people say, oh, it's a premature optimization. We'll do it later on. We have, it's not big enough. Like you see, we have like a class here it's like 6 or 7 lines, so I can do it later on. Let's put everything in the same place. But the problem is that nobody. Oh, I have to finish. The problem is that nobody actually knows when it gets too big, because people will come to update it, add more, and suddenly it's a ginormous package or trait, and it's impossible to maintain. And then someone says, I'm not going to touch that. That's too big. I'm not gonna go in there. So try to do it now. So I think I'll just do just one section because it's very short. The test action itself, it's a very simple part. The simple part of this is you should at first try to stick to have it just a single statement. And another thing is don't hide it, because this is the thing that you're testing. And unfortunately, I ran out of time, because actually this lecture was supposed to be a little bit longer, but apparently it's shorter. So the takeaways that I want you to go out with this one is try to test the behavior and not to test the code itself. And every test should stand on its own. Start to do it today. Start to refactor today. Start to learn how to do it and try to play with it more and more, because if you wait, it's going to be too late very, very soon. Describe everywhere what you do and not how you do it. And this one I didn't cover, but only use in the test things that you define in the test itself. And unfortunately, I ran out of time. So I'll be around here if you want to ask me more and more questions. I'll be happy to answer them. And also, this is my email, or so if you want to ask me later on, you can catch me later on. But thank you very much. Sorry I didn't manage to cover everything. Thank you for listening. Do you want to? We have some time for questions, or no? Sorry.
Related to Scala, of course, but I'm just saying that people should keep their code clean and just have fun with it, because Scala is a very fun language to play around it and have fun with it. But remember that you have fun in your personal experiments. Make sure that you also you're considering other people who has to review that.